This is 11.5 lesson in the Big Ideas book. It's all about volume. See if we can get through some of this today. First of all, I have some cubic inches here. I've just cut out with a saw so that we can talk about volume, because anytime we're going to measure volume, we're going to measure it in cubes. We have to think about a three-dimensional object, something that you can actually get a hold of. Okay, so you can pick it up, you can rotate it around, and then we're going to measure how many cubes it takes to fill it up. And depending on how big that object is, we're going to use different size cubes. So something that's fairly small, we might use cubic inches, or maybe even cubic centimeters. Okay, or something larger, we might use cubic feet. Some of you might remember the cubic foot that we have in my room in the back corner there. Or even cubic yards, something like cement. When you buy it, you buy it by the cubic yard. So if you can imagine a cube that's 1 yard by 1 yard by 1 yard, that's a big cube. Some people even measure volume in cubic miles. So I heard recently a construction project going over a mountain, they moved a cubic mile of dirt. So that's a lot. So first of all, we're just going to talk about how these figures work, and I'll start with a little 4 by 4 by 1, so you can see that it's 1 unit tall, and its volume is 4 cubic units. So if we have 4 times 4 times 1, the height right here is 1, then we're going to have 4 cubic units. And that's the way we find the volume of any object like that, is basically area of the base times the height. If it's a right solid like this, or even a prism or a cylinder, which I'll show you in a minute, we can do that. Now as the height changes, okay, so I stack up a little bit more on here. So now that you can see, this one is 4 by 4 by 2. So 4 times 4, excuse me, 2 by 2 by 2. So 2 times 2 is 4 times 2, so we have 8 cubes. And you can see, in fact, we do have 8 cubes. And there's the same 8. This time it's 4 by 2 by 1. So we still have 8. And that just continues on. So that's the way we're going to work with volume. Give me my first paper here. So our core concept today is volume of a prism or a cylinder. And this is how the formula is given. Volume equals capital B times H. You need to remember that capital B stands for the area of the base. Not just the base, not just the length or the width of something. It's the whole area of the base. So let's take a look at a prism here. Okay, so you can see our three-dimensional prism. Let me draw this back lines in here so that you can see those. And let's say this one is 6 centimeters by 4 centimeters by 10 centimeters. And I want to find its volume. Okay, so what I'm going to do is I'm going to find the area of this base. Okay, so 6 centimeters times 4 centimeters. And then I'm going to multiply by the height of the object, which is 10 centimeters. Now at this point you can see that it doesn't matter what order we multiply this out in. You can do it in whatever order you like. And one of the reasons you can think of it that way is it really doesn't matter which side is the base in this particular case. If we want to rotate it and say that this is now the base, it really doesn't matter. Any side of this particular object can be the base. And you can see it here. We can do it the same way. So 6 times 4 is 24, times 10 is 240, or 10 times 4 is 40, times 6 is 240, or 6 times 10 times 4 is 240. But something else you really need to watch is that centimeters times centimeters times centimeters is cubic centimeters. Okay, so there's our volume. Another object, let's say this particular object is a triangular prism. And we want to find its volume. We're going to need to find the area of the triangle here on the end and then multiplied it by this length right here. And that might seem a little odd, but the bases, the two bases, okay, it doesn't matter how we rotate the object or turn the object, those two are the bases, the two sides that are parallel to one another like that. And if, I suppose I could turn my paper here so that it maybe looks a little bit more like you want it to. And then we can say, okay, here's the area of our base, that's the triangle right there, and then this is going to be our height. Okay, so the two sides that are parallel. So what I would do, let's say we have 2 times 6 again, and we'll just make this 10. Okay, we're going to take the area of our base, this is now in inches, so half of 2 times 6, 2 inches times 6 inches, that's the area of the base, or 6 square inches, and then we're going to multiply that by 10 inches, and we end up with 60 cubic inches. Okay, cubic inches, and there's our volume, area of the base times the height. The next one we want to talk about is a cylinder, a circular cylinder, where we have a circle on top and then a cylinder like this. So it looks something like a can of pop or something like that, okay? A drum, a barrel of oil, I don't know what you want to call it here. But we're going to have a radius, we'll say that's 3 feet this time, and we're going to have a height which is 8 feet in this case. So if I'm going to find the volume, I'm going to find the area of my base, which is this circle down here. Okay, so I'm going to go 3 feet squared times pi, and then I'm going to multiply that by the height, which is 8 feet. Okay, so 3 squared is 9, so we have 9 times 8 is 72 times pi, and then feet squared is square feet, and then square feet times feet is cubic feet. So there's our units, work out to be cubes, which it must if we're talking about volume. And this is the exact answer. If I need to give the answer to the nearest tenth or the nearest hundredth, I'll get out a calculator. I know you guys could type that in, get an estimate, but this is the exact answer, and I prefer to write it that way, partly because I'm lazy and partly because that's the exact answer. Okay, so that's basically how we find volume. And again, if I were to give you this cylinder laying down on its side like that, that's not going to change which two sides are the bases. The bases have got to be the two sides that are parallel to one another, those two sides. Okay, so if I lay a can of pop on its side like that, that doesn't change which side is the base. Okay, all right. I've got to move along a little bit here, or I'm going to run out of time, and this isn't going to download to YouTube or upload to YouTube, so you can rewind. This one, they give you a chest, and they want the volume to be 36 cubic feet, and we know the length is going to be 6 feet and the width is going to be 2 feet, and we're just worried about what the height is going to be. So you think about our formula, area of the base times the height, which would be, I suppose, the length times the width. That would be the area of the base, and then times the height, that's our volume. If you think about this formula, we're given 3 of the 4 variables. We know what we want our volume to be, 36 cubic feet. We know the length has to be 6 feet, and the width has to be 2 feet. And we're simply looking for the height. Okay? So I wanted to kind of point this out one more time here. I'm going to divide both sides by 6 feet, and I'm going to divide both sides by 2 feet. So 6 feet and 2 feet. You can multiply them together first if you like and say 12 square feet. But I want these to cancel, so I have h by itself. Okay. Now over here, I want you to notice that feet here and feet here are going to cancel 2 of the cubic feet. All right. So feet cancels 1, feet cancels 1. I'm down to feet. And then 36 divided by 6 is 6, and 6 divided by 2 is 3. Or if you prefer, 36 divided by 12, that's 3. But it comes out in feet. The units work out. If you do it correctly, the units will work out the way they're supposed to work out. So you'll get cubic units per volume, or in this case, we just get feet because all we're looking for is the height. Okay, now on to Cavalier's principle. Cavalier's principle talks about how if two objects have the same cross-sectional area, so if we were to cut through them and look at the cross-section that is created in here and the cross-section that's created in here, and those two cross-sections have the same area, and these two objects have the same height. Now the cross-section has to be the same all the way up, so I couldn't have something, say, that came to a point. We're going to talk about these type of objects later. But you can see this one might have the same cross-sectional area at the base, but not at every single level. Its cross-sectional area changes. So these have the same cross-sectional area at each level, okay, all the way from the top to the bottom, and they have the same height. So therefore, they're going to have the same volume. If their bases, area of their bases are the same and their heights are the same, they're going to have the same volume. These two, you'll notice this is a right circular cylinder, so this is at a right angle right here. This one's not a right circular cylinder. However, they have the same radius and the same height. So their bases have the same area, radius squared times pi. They're both radius squared times pi. And they have the same height, so area of the base times the height is going to be identical for each one, regardless of the fact that this one's kind of leaning over a little bit there. Okay? You'll notice that the bases are congruent shapes here, and they're parallel to one another, so we can find the volume by area of the base times the height. And even in a case like this, okay, these two shapes are going to have the same volume. This might seem a little weird, but this one right here, radius squared times pi, radius, here, I'll put it down here, radius squared times pi, that's the area of the base, times the height, so r squared times pi times the height. I suppose we should write that out. R squared times the height times pi eventually. And over here, let's think about the area of the base of this object. We're going to take r radical pi times r radical pi. So r times r is r squared. Radical pi times radical pi is just pi times the height. And there they have the same volume, regardless of whether they have the same shape or not. Same base, same height, they're going to have the same volume. We're going to stop right there. I don't know if the rest of the lesson will fit on. I might make another video today, and I'll try to get this uploaded for you. Thank you.